So here are a couple of examples from page 202. We're going to start with this set here. The directions say, state whether or not the function satisfies the hypotheses of the mean value theorem on the given interval, and B, if it does, find each value of C in the interval AB, the open interval AB, that satisfies the equation f prime of C equals f of B minus f of A over B minus A. All right, we're going to look at number 4. So it says absolute value x minus 1 on 0 to 4. All right, so what I want you to say for this one is you're going to think, okay, what does this look like? So I know that absolute value of x looks like that. And by the way, have I mentioned that you really need to understand transformations in this class? Because you do. This minus 1 is a shift to the right. This is why you learned about transformations. So here's absolute value of x minus 1. All right, you don't need a graphing calculator to tell you that. You need to know the parent graph and the transformation. All right, so now you're going to look at this and you can say, oh, there's a non-differentiable point in the interior of 0, 4. So you're not just going to state whether the function satisfies the hypotheses, like the book says. You're going to state why it does or does not meet the hypotheses. So you're going to say f does not meet the hypotheses of the MVT because f has a non-differentiable point at x equals 1, and you could note because there is a cusp there, all right, and 1 is in the interval, the open interval 0 to 4. All right, so when you're talking about differentiability, you want to refer to the open interval. If I'm referring to continuity, I would refer to the closed interval. All right, and so remember there's two hypotheses, differentiable in the open interval, continuous in the closed interval. If you're going to say that f does not meet the hypotheses, then you only need to state one criterion that was failed. Whereas if you want to say that it does meet the hypotheses, you have to state that it meets both of the hypotheses. All right, so that is number 4. Now we're going to do number 6. Number 6 has f of x equals ln of x minus 1 on the interval 2, 4. Okay, so again, we need to understand the parent function is ln x, and we need to know the transformation is a shift 1 right. So here is ln of x minus 1. This point is 2. And so our interval 2, 4 is here. We can observe from the graph there are no discontinuities or non-differentiable points in 2, 4. So you're going to say f does meet the hypotheses of the MVT. And by the way, up here I should have said on that interval because it just depends on the interval. On 2, 4, because f is continuous on 2, 4 and differentiable on the open interval 2, 4. All right, so you don't have to go back another and state why it's continuous, why it's differentiable. You just have to state that it is, and we observe from the graph that it is. All right, then we have to go the next level and do part B. It says, if it does, find each value of C. All right, so we need to solve f prime of C equals f of B minus f of A over B minus A. So let's see, if f of x is ln of x minus 1, then f prime of x is 1 over x minus 1 times 1, because there's a chain rule. This is an inside function, but its derivative is simply 1. All right, and then a is 2, b is 4, a is ln of 1, which happens to be 0, and b is ln of 3, which we'll just leave ln 3. Okay, so we're going to solve our f prime of c, so we're going to solve 1 over x minus 1 equals f of b minus f of a. Oh, this is f of a, and this is f of b. Sorry about the omission. So we're going to solve ln 3 minus 0 over 4 minus 2. All right, so then 1 over, oh, and this really should be a c, because it's f prime of c. All right, so 1 over c minus 1 equals ln 3 over 2. Let's solve this with as a proportion. So c minus 1 ln 3 equals 2. So c minus 1 equals 2 over ln 3. Look at all the algebra you got to do. C equals 2 over ln 3 minus 1. Now, if you want to just confirm your answer here, like I like the answer 2 over ln 3 minus 1, but if you want to just get confirmation that that answer makes sense, you find your calculator, which I'm scrambling to do in a moment. I know, here we go. It was where I thought it was, but it's lying down sideways. All right, let's just verify that 2 over ln 3 minus 1 is actually in that interval. That's sort of a check on my work. I know there has to be a point and there's only one solution, but that would be a good way to check what I've got here. So let's do 2 divided by ln of 3 minus 1. And I get 0.8204. That is absolutely not in the interval 2, 4. So something is wrong. As these seconds tick away on my video. I do not see it. What it makes me, oh, I see it, I see it. This is c minus 1, this is supposed to be plus 1. You guys probably spotted that right away. I almost gave up and redid the whole video, but I spotted it. Okay, so this really should be plus 1, and that's 2.82. It is in the interval. But see how checking to see that my solution was in the interval allowed me to catch an error that I had missed? That's why you check to make sure the C that you get is in the interval. All right, so there you go. Gertie likes it. Check it out, Gertie. What do you think? Is it good? Gertie's like, I don't care. I'm just going to sniff all your stuff. Gertie, give us a big smile. Just want to give us a big smile. Okay.